Good morning, everyone. As you all can see, I am obviously not in school today. The plague is still going through my house, and at this moment in time, as of recording this, I am still the last man standing. So in light of that, I am going to give you guys another extension on your weekly assignment. I'm going to make it due on Monday, so that way if you guys have any questions, you'll have plenty of time to ask me in class when I see you on Monday. This week has just been kind of a disaster. So in the effort to stay motivated and supportive and academic, I'm going to make a video for you today on a couple of things. One, just being quickly t-tests, whether that's a 1 sample or a 2 sample. This did show up on your weekly assignment previously, and a lot of people came to see me about it, but it's very similar to a T interval, so I don't imagine it'll be too bad. And then the other thing I'm going to talk about is a one-sided versus a two-sided test. That's another concept that will come up on the AP exam. So, in general, a t-test, or a one-sample t-test, we use when we're testing for a mean. But our population standard deviation is unknown. So very similar, and I shouldn't even say similar, exactly the same as a T interval. When we're trying to make a guess, a guess is a confidence interval or an estimation, and here testing a hypothesis about where a population mean is given some sample data. So if I look at my Harry and the new cat, right, my hypothesis now is just going to be something like mu equals 10, let's say. Right, your null hypothesis is still written as an equal to statement. That doesn't change. For my alternatives, I still have the same 3 options. Right, I could have greater than 10, I could have less than 10, and I could have not equal 10. So, same 3 options. For my assumptions, I still need to have a random sample. And again, from the problem, we're going to quote that. And 2, from my central limit theorem, it is exactly the same, where I need n to be greater than or equal to 30. There is no special thing here. I know with a 1 proportion test, we were using the null hypothesis proportion for the CLT. But in this case, it's just based on the sample size. So the assumptions are exactly the same as a T interval. Identical. For your test, it is a 1 sample t-test. Your actual formula, I'll write out later for you. But your numbers, you're going to need T, you're going to need P, and then the very last thing you're going to need is going to be your degrees of freedom. And degrees of freedom here stay the same. It is still n minus 1 degrees of freedom. And so my conclusion also remains the same as any other hypothesis test. I'm either going to reject or not reject. And then based on that, I'm going to say whether or not I have evidence of my alternative hypothesis. So first I figured we would go and look at an example here, right? And at least do 1 full out. And then I have another example where you're given some sample data before we talk about some 2 sample stuff, right? So, in this particular case, right, notice our sample size isn't actually big enough here. They test 22 patients, but we're going to assume we have that normal distribution. So if I read this, this is about patients with schizophrenia, and we found that healthy volunteers average a score of 51. So that's going to tell me that my null hypothesis is that it's equal to 51. And my alternative, I have to fix this because it's going to bother me. My alternative, right, if we take a look at the last sentence, they claim, right, or they believe that patients with schizophrenia, I'm on the eraser, that's not helpful. They believe that patients with schizophrenia will score less than the average. So very simply, just mu is less than 51. For my conditions, let's pretend it's random. And for the central limit theorem, in theory here, I would need to make a box plot or something, or I would need to be looking for the sentence of assume it's approximately normal. So we're just going to stick with the same old, yes it is. And so my test is a one sample t-test. The formula looks very simple. It is x bar minus mu sub 0 over s over the square root of n. The only thing to keep in mind here, this mu sub 0 is just from your null hypothesis. And the x bar, that's right here, this is your sample mean. Now, obviously we can do this whole thing on our calculator as well. So, to show you that, right, here is my fake TI calculator, right, which right now is not working. Let's try this again. Let's go back here. Let's go back here. Let's refresh the page. Let's try that. There we go. Okay. So, under the stat menu, and then under tests, this is just a standard t-test. And in this case, I'm going to be inputting my stats. So my null hypothesis was that it was equal to 51. My sample mean was, I believe, 39. I'll double check that. Nope, 39 with a standard deviation of Walmart ad. There we go. Oh boy. This is not good. T-test. Get rid of this. I don't need to see any of this. Can I use this calculator? That would be so cool. Okay. X bar was 39. Standard deviation was 4.3. And my sample size I know was 22. And we were testing less than. So now I just go calculate. Yeah, what a surprise if we take a look at those numbers. My p-value is 11 zeros followed by a 7. So when I actually go to do this here, right, my t-value was about negative 13. My p-value was essentially 0. And my degrees of freedom, in this case, would be 21. And so in conclusion, since p is about 0 is less than alpha equals 0.05, comma, we reject our null hypothesis. There is sufficient evidence to suggest that, and I'm just going to fill in mu is less than 13. In reality up here, I should be defining what mu is. I should say that mu is the true mean score on this test for patients with schizophrenia. Again, this is something that you guys have done before. We did this on our last weekly assignment. It is very similar to a one sample t interval. It's just now a hypothesis test. The other type of question you might see is a question like this one, where now the only difference is we have to make a box plot. All right, because notice we have 10 data points and I'm given the data, right? Because I am given the data, that is how I know. If you ever see a data table like this, my immediate thought is that I got to be making a box plot for this. My sample size isn't big enough. They gave me all this sample data for a reason. All right, so just checking here. So you see this very last thing here. Is there any evidence to suggest that Sarah's belief is incorrect? This leads me to, actually I shouldn't say P there. I should say mu. This leads me to a not equal to alternative hypothesis. So she believed they sleep for 6 hours a night. This is college students. Do we have evidence to suggest that she's wrong? Just means it's not 6. Notice how they don't give you a specific direction. They're just saying more than 6, or they're not saying more than 6 versus less than 6. They're just saying not 6. So if I go to my calculator here, right? Hopefully this works now. I'm going to put all this stuff in my lists. So I had 7.2. 7.2, 8.7, 5.4. This is going to get messed up every time I do this, but that's okay. 5.9. And the last person, 4.2. So now when I go to do the t-test on my calculator, instead of selecting stats, I'm going to select data. Just make sure you set your hypothesis to be the correct number. And in this case, I'm testing not that. Oh boy. Just zoom out when in doubt. I'm testing not equal to. And so here is what my result ends up being. And probably not so surprising here, right? With that p-value here, I'm not going to be rejecting my null hypothesis, but my sample mean was 6.3. That's not that different from 6. And I have a small sample size, which means I'm even less confident in it. So, right, in this particular case, that was my t-test. Remember, to make the actual box plot here, right, I would go second y equals, turn this on. This is going to be really frustrating for me, but that's okay. Make the box plot and then zoom 9 for zoom stat. And as you can see, we have no outliers and it's a fairly symmetric box plot. So we would make the box plot, copy that over with the number line. Unfortunately on this, I can't like click and drag like I can on the TI Smart View to put in our Smart Notebook, but you guys have the video. Now, a 2-sample t-test is going to be really similar, except now we just need 2 different populations. And we're testing for a difference in means. That's all. We're testing for a difference in means. So when I take a look at this example, right, this is a very basic example that you can probably tell I used ChatGPT to help me generate the sample data here based on that screenshot. But we're just trying to determine if there's a difference in test scores. So again, I'm trying to emphasize this difference with the not equal to alternative hypothesis, right? Because we haven't seen that a lot, and we've got 35 people in each group, right? So again, with a 2-sample t-test, your conditions are the same. They just have to be true for both samples instead of one sample. And so in this case, I'm going to go back to my calculator, right? And now it's stat tests, and no surprise, it is a 2-sample t-test. And so there's a whole lot to do here. But the first sample mean was 82 with a standard deviation of 5. What's going on here? Zoom in. This is not going well for me. There we go. 82, standard deviation of 5, sample size of 35. I know the second one was 78. And a standard deviation of 6 now. 35. We're testing not equal to, and same deal here. We're going to leave pooled off. And we're going to calculate. And so here's what I get. Again, notice you get the weird degrees of freedom from your calculator. So all I'm going to do, copy this stuff over. T equals 3.03, P equals 0.003, and the degrees of freedom of about 65.86. And in this case, I would reject my null hypothesis. I do have evidence to suggest that there is a difference in test scores between the people here who use the study guide and the people who don't use the study guide. What I will do here is I will include screenshots of all of this for you afterwards here, because otherwise it will mess up the screen recording of the iPad. And I don't want to record this video again. I recorded a video for period 5 and had to do it 3 times and was almost losing my mind. So I will include the screenshot in here afterwards of the PDF that I end up exporting for you. But yeah, otherwise, that's what we got for t-tests. I'm actually going to save, based on how long this video is, I'm going to save the one-sided versus two-sided testing for Monday. And so, again, weekly assignment, you'll have the weekend. Yeah, I hope you guys have a wonderful weekend, and I will see you all on Monday. Bye.